Okay, so last Friday we started talking about quadratic models, and I introduced two types of problems. And you guys actually worked with your pods, and you were able to kind of problem solve. Okay, if I'm given a vertex, I'm given a point, I'll plug these things in and I'll solve for A. So it really wasn't too terrible. I said, and I mentioned, I showed you this core concept. It's in your textbook. So I said you didn't have to write it all down. But there's a third version where instead of being given specific points like the vertex or the x-intercept, you're just given 3 points. So 3 xy ordered pairs anywhere on the parabola. In order to write the model, this model is going to come out to be y equals ax squared plus bx plus c. That's the standard form. But remember when we talked about standard form, we don't really know anything in standard form. I mean, we do know the y-intercept is the c value if we plug 0 in for x. But other than that, like, we don't know the vertex, we don't know the intercepts. So standard form doesn't really tell us a lot, which means in order to write the equation, it's a lot more work. Okay? In order to write the equation, we're going to be using our 3 variable systems from chapter 1. So we're going to model that today. All right. Here's our example. The table shows the estimated profits for a concert when the charge is X dollars per ticket. And we're going to need these values. So this is going to be our one example. So I'd write this down in my notebook. I would write it down. Yep, I'll put that table in there for sure. And it says, write and evaluate a function to determine what the charge per ticket should be to maximize the profit. Okay, so we've done problems kind of similar to this back in chapter 1, but in chapter 1, when we got a table of values, we kind of checked the data to see if it was linear. So we would see like, okay, as x increases, is y also increasing? Or as x increases, are the y's usually decreasing? And do you remember when we like plotted them and looked to see that they looked like they were on a line? And we did the line of best fit. Okay. And so then we would model it y equals mx plus b. Now, notice as the ticket price increases, in the beginning your profit is also increasing, but as you progress and you raise the ticket price too much, then your profit starts to decrease. So we can already see that we're going up and then coming down. So we're thinking this is probably not necessarily a linear model, but I should model it after something else, and we're going to be thinking about quadratics here. So there is a test to determine whether data can be modeled by a quadratic, and it uses second differences. Okay? So one way that you can test to determine if data is linear is by their first differences, as long as x is moving by the same amount, and we're moving up by 3 each time. Okay? So the first differences would be things like 6,500 minus 2,600. So I'm thinking 6,500 minus 2,500 would be 4,000, but I have 100 less, so 3,900. And then 86,000 minus 65,000, 2,100. And I can see already it's not linear, right? Okay, but I'm going to keep going. 89,000 minus 86, or sorry, 8,900 minus 86,000. I apologize if I'm saying 1,000 up here. And then what's 7,400 minus 8,900? Negative 1,500. And then 4,100 minus 7,400. Negative 3,300. Is that right? Okay. So these are called the first differences. If those first differences were the same, then we would essentially have slope, and it would be linear. But obviously, it's not the same, and it's changing. Like, it's increasing, but then it's increasing by less and less as it approaches the maximum, and then it starts decreasing. And as you would continue, it would decrease more and more as it moves away from the maximum. So in order to test if something is a quadratic model, you can check your second differences. If your second differences are the same, the quadratic will be an exact model. If the second differences are not exactly the same but close, you could probably do like we did with the line of best fit. We could find a parabola of best fit, but it wouldn't be exact. Okay? Now, do this again. 2,100 minus 3,900. Negative 1,800. 300 minus 2,100. Negative 1,800. Negative 1,500 minus 300. Oh, negative 1,800. And the last one, negative 300 or 3,300 minus negative 1,500, so that would be plus. That's going to be negative 1,800. Okay, so because my second differences were all the same, it would be quadratic. Now, I wouldn't necessarily worry too much about that part, but it is helpful later on, like as we learn more about polynomials. If your second differences were the same, but your third differences were, then you could use a cubic polynomial to model it. And you can just keep extending that. So you could figure out what the degree or the highest exponent of your polynomial would be. Okay, so at the very least, we know it's quadratic now, which we kind of suspected from the way the data was moving. Now we're going to write and evaluate the function. Okay, if I give you a table of values like this, remember that in that core concept that was in the textbook, it said given 3 points. Okay, so you can choose any 3 points that you want. My guess is you'll try to choose points with lower numbers if possible. In this case, I just noticed all of these numbers are fairly large in the y value, but for my x's, I could at least pick the 2, 5, and 8, so my x's is smaller. So I'm going to use these 3 as my 3 points. So I'm going to treat that like 2, 2,600, 5, 6,500, and 8, 8,600. Okay, and those are not necessarily intercepts or vertex. Okay, they're just random points on the graph. So each of these could be an x and a y. And then we're going to use the standard form, y equals ax squared plus bx plus c. And we're going to sub the x and the y in for that 3 times. So I'm going to start with 2, 2,600. Y is 2,600 equals a times 2 squared, which would be how many a's? 4a. Plus b times 2, 2b plus c. So when you actually plug in your xy ordered pair, you have to square with the A and then just use the X for the B, but it actually writes a pretty simple equation right there. And then you do it again for the next point. This time 6,500 is my Y. It's equal to A times 5 squared, which is how many A's? 25. 5 times 5, 25A. Plus B times X, which is 5. Plus C. And then we do it one more time. 8,600 equals A times 8 squared. 64A. Plus B times 8. Plus C. Questions, concerns about where I got those things? Okay. All right. So then, this is row 1, row 2, row 3. What's going to be the easy variable to eliminate? C. Yeah.
Yes.
Okay. So we have to eliminate C twice. I'm probably going to use row 1 and row 2, and then row 1 and row 3. It doesn't matter which two sets you use.
You should subtract the whole thing.
I'm going to do row 1, I'm going to multiply by -1, and then I'm going to keep row 2. You could do it the other way, it doesn't matter. So this is going to be -2,600 equals -4A minus 2B minus C. Make one of them all negatives, or subtract the whole thing. And then 6,500 equals 25A plus 5B plus C. So what is this? 3,900 equals 21A plus 3B. And that's my new equation.
You subtracted all three together.
No, you can't do 3 at a time. You can only do 2 at a time.
Why not?
Well, because then you wouldn't
Okay, I see it now.
be able to solve for a variable. You can only do 2 at a time. Now I'm going to do row 1 again, and I'm just going to use the same thing, -1 row 1, and then I'm going to do row 3. So that's -2,600 equals -4A minus 2B minus C. Copy the third one, 8,600 equals 64A plus 8B plus C. What is that, 6,000? Equals 60A plus 6B. And that's row 5. Now look at row 4 and row 5. You've got A's and B's. What's going to be, did I make a mistake? Yeah, now which letter is going to be the easiest letter to eliminate? A or B?
B.
B. Right, I've got a 3B and a 6B, so let's multiply row 4 by -2. Excellent. Okay, so I'm going to write -2 times row 4 and row 5. So what is that? -7,800?
Yeah.
Equals -42A minus 6B. And 600 or 6,000 equals 60A plus 6B. So add down here, we're going to get -1,800 equals, this is 18A. If you still have a B left over, you don't multiply by the right thing. Right? That's no good. And A equals -100. So after I find A, I can go back to row 4 or row 5 and find B. Okay, so I'm going to go to row 4. And I'm going to do, in row 4, 3,900 equals 21 times negative 100 plus 3b. So that's 3,900 equals negative 2,100 plus 3b. Add my 2,100. So am I at 6,000? Equals 3b divided by 3. And b equals 2,000. Yeah, some big numbers.
Almost done.
Let's do row 1.
And then plug into row 1. Did you have a question, Susan?
Oh, no.
So after that, I'm going to plug into row 1. Can you guys read me what row 1 is?
26,000 plus 2,600 equals 4a plus 2b.
4 times a, which is negative 100, plus 2 times b, which is 2,000, plus c.
Yeah.
Okay. And so I get 2,600 equals, this is negative 400 plus 4,000, so 3,600 plus c. And then subtract. And c is negative 1,000. Okay, so the model should be y equals negative 100x squared plus 2,000x minus 1,000.
Oh my gosh, my head hurts. I'm so
It's okay, I'm okay with it. You should be too. Miss Cronky doesn't like whining. You're not in Algebra 1 anymore, just like Dorothy's not in Kansas. Moving on.
Cheese with that wine?
Yeah. I used to have a saying, the more you whine, the more I assign. I don't say that. I already have my assignment picked
She
out.
doesn't say that. She knows better.
Now, if you were dying to know if you had the correct model, you could go back up here to the top, and you know, we picked these 3 points. You could pick any one of those 3 points, or you could have picked like 1470, 400. And if you came down, you could check 1470, 400. Put 14 in for all the x's, and what should you get out for y? 7,400. So that's a way if you're ever like, I don't know if this seems right when you're on your quiz or your test and you want to come up and ask me, is this right? I won't tell you, but you could check it yourself. Okay, so that's your homework, or that's basically all you have to do on your homework assignment. Rather than do another example, I'm just going to let you work on your homework assignment. Okay.
I really wish.
Sign out and take the pass.